looking today at stretches and compressions, so different type of transformations. And so when we look at it, if we change the input or the x, it's going to cause a horizontal change. So same as when we move the vertex left or right, causes a horizontal change. And then if we change the output, or f of x, that's going to cause a vertical change. And so if we look at it, it's either going to be a stretch or a compression. And it's a transformation that makes it wider or narrower. So either way, it'll make it either wider or narrower. So they use multiplication for this. So it's multiplying by either the x or the f of x. So multiplication. So using multiplication there for that. If you multiply by the x, that's the input. Again, that will be inside the parentheses. And the output, f of x, is outside the parentheses. So let's look at an idea of how this works. So if I have 3 times f of x, anytime now 0, 0 will still be the same here. But if I move over to 1, I'm going to do that times 3. And so that would be at 3. And if I do to 2, 2 squared. And so I'm doing really just 3 times x squared is what's happening here. So doing 3 times x squared, so 1 times 3 would give me 3. If I do 2 squared, that's 4 times 3 is already going to get me up to 12. And then when I do 9 times 3, that's already up and off of the chart. So that's going to stretch it significantly, which makes it narrower. So g of x, narrower. And the vertex is still 0, 0. And that's no change from where it was. Okay, then if we do, and this is a stretch. So then if we do 1/2, I'll think of it as 1/2 times x squared. So when I'm at 1, it's at 1/2. And when I'm at 2, it'd be 2, 2, because 2 squared is 4. And 4 divided by 2 would be 2. And if I do 3 squared, that's 9. Let's do 4 squared. It'd be 16. So at 4, it'd just be at 8. And so we keep on going up in that manner. So this one ends up being wider. And I should have probably used some different colors on that so you could see it a little better. But this one is g of x. And this one is h of x. So we've got one that's a little bit narrower, one that's a little bit wider. And we can just kind of highlight these. So we notice a little bit of a difference there. There's my h of x. And so this is going to be a compression. And h of x is going to be wider. And still, vertex has no change. It'll still be 0, 0. So, for our notation, if it's a times f of x, or a times x squared, remember it's outside the parentheses that a is, so it's going to be the output. And if it is a fraction, so less than 1, if a is less than 1 but greater than 0, compression. And it's going to be wider, which means if a is greater than 1, it's going to be a stretch, and it'll be narrower. And all these are vertical. So vertically, it's compressed, and vertically, it's stretched to make it narrower and wider. Then looking at the horizontal side, and what's can be a little bit more confusing here is that when we do 3 times x here, then the stretch is actually going to be it's actually going to be a horizontal compression, which is the same thing as a vertical stretch, essentially. So if I do 3x, which means I'd be doing 3x squared. So when x is 1, I do 1 times 3 is 3, and then 3 squared gives me 9. And 2 times 3 would give me 6, and that's already way up to 36. So this one ends up much more compressed than my other one. So compresses a lot faster because you're multiplying before you square the function. And that's the g of x. Then same thing for the compression. If I do 1/2 x, then we're saying it's 1/2 x squared. So if we go to 2 times 1/2 is 1. So at 2, we're only at 1. If I go to 4, so 4 divided by 2 is 2. Squared would be just 4. So here we're at 4, 4. And then we could go out to 8, which is 4, so that'd be 16. Just to give you an idea of how much wider this makes it. So it gives it a decent stretch there going through. And that's for h of x. And so let's define a few things on this. So this was a horizontal compression. And so g of x is narrower. And still on the vertex, there's no change. Might be noticing a common theme there. And finally, for my 1/2, so if it's a fraction, that's going to be a stretch. And h of x is wider, and vertex is still going to be 0, 0. And so our notation for this, we do f of b of x, which would be b of x squared. And that's the input because it's inside the parentheses. So if it's a fraction less than 1, it's a stretch. And that's wider. And if b is greater than 1, that's a compression, which makes it narrower. So inside, it either pushes or pulls it from the side. If the number is outside, it's going to either push or pull it from the top and bottom. So stretching it left and right or stretching it up and down is basically what we're doing here. So we'll take and look at a couple of examples here in just a second. So looking at a couple of these here, wants us to determine if the input or output's being changed and then describe what the effect is. Won't have us put the vertex because, as we can see, for right now, these are always going to be the same. So looking at the first one, the 6 is inside the parentheses, so that's going to be the input. And so my input is going to be horizontal. So when it's with the x, that's horizontal left and right. And it's by a whole number, so that's going to make it, it's going to be horizontally compressed. Which would make it narrower. Then on the other end, it would be outside the parentheses, just like my 3x squared here. So that's going to be the output, which is going to make it, that's larger than 1. It's going to make it vertically stretched, which is going to also make it narrower. So looking at this, if you compress it horizontally, so pushing it inward from the left and right, that makes it narrower. But also pulling it from the top and bottom is also something. So like you think of like when you've got silly putty or Play-Doh or something like that that you can pull and stretch, that pushing it one way and pulling it the opposite really have that same effect. And we'll look at one more. Here we've got a number less than 1 for the input. And so that's just going to do the opposite of what we had here. So horizontally stretched, which is going to end up making it wider. So you've got some examples on that and some practice with it. And then we'll be looking at it, at taking it and using it with more than just that.